Hello students. So in the previous lecture I had introduced to you about the basic concepts of redox reactions. If you are already not familiar with the basic concepts, I request you to watch my introductory video on the redox reactions. Now we further go on to the next topic, that is the oxidation number, and what this is and in what way this is going to be useful to you in a little bit more of advanced studies of redox reaction. This I'm going to tell you in this lecture, and I'm going to assume that you hardly know anything. So even if you don't know some of the very basic concepts in chemistry, you will be able to follow this lecture because I'm going to explain you in a very simple language, giving you lots of examples and also going at a slow speed so that you can follow me properly. So let's start with the concept of oxidation number. So basically, what do we understand by oxidation number? Basically, oxidation number refers to the charge that either it is quite obvious uh, for an element or sometimes it is not obvious. So let me explain this to you with an example, that suppose we write NaCl. Now you already know that Na has got a +1 charge and Cl has got -1 charge. The other way of saying this is that the oxidation number of sodium is +1 and oxidation number of chlorine is -1. So this is the charge that you see, that is the oxidation number. Similarly, if you go to the next example, say for example CaCl2. Now going further, as you already know that chlorine has got a -1 charge, so two chlorines together have got a -2 charge. Since the overall charge must be equal to 0, therefore to balance this -2 charge, calcium should have a +2 charge. Now this +2 is the oxidation number of calcium in calcium chloride. So oxidation number is simply the charge that you see in an element when it is combined. Now when it is not combined, for example, if it is only sodium, or if it is just calcium, or if it is just chlorine, then it is easy to understand that it has no charge, because the number of protons is equal to the number of electrons and there is no loss and gain of electrons. So whenever the element is in the free state, when it is not combined with any other element, then the oxidation number for that element or for that atom is taken to be 0. So this is quite obvious, and if we just write it as Al3 plus and you are asked what is the oxidation number of aluminium, obviously it is +3. If you write O with a 2 minus, obviously the oxidation number of oxygen is -2. So this is like very apparent about the oxidation number. But if I write a formula like KMnO4 and then I ask you about the oxidation number of manganese, then it will be not easy for you to find out the answer. So we have made certain rules, and with the help of those rules we can assign an oxidation number to manganese. So the oxidation number can be positive, as you can see it can be negative, it can be 0, sometimes it can even be fractional. So that is the apparent, we see the apparent charge that an element is supposed to be having when it is combined with other atoms, even if it is a covalent compound, like these are ionic compounds. This is a covalent compound. So MnO4 minus, this is covalently bonded. So how to find out the oxidation number in those cases? For that we have framed certain rules, and I'm going to explain you those rules. So with the application of those rules, you will be able to find out the oxidation number for the different elements that I'm going to discuss with you just now. So in my next slide, I'm going to discuss with you what are the various rules for assigning the oxidation number. So just wait, I'm going to the next slide and you will understand how we give the rules. Okay, so let's go further. Oxidation number rules. So see, the first rule is quite obvious, that the oxidation number of any uncombined element is 0, and that we already discussed, like when it is like S8, sulfur, or Cl2, Zn. So these elements are not combined with any other element. Chlorine is combined with itself, sulfur is combined with itself. So in that case, the oxidation number for that element is 0. Okay. Now, if you consider group 1 elements of the periodic table, like group 1 like sodium, potassium, lithium, you know, they generally have an oxidation number of +1. Reason is that they have a tendency to lose one electron. For example, if I take a group 1 element, right? If I take a group 1 element like let's say sodium or potassium, right? Let us say KCl. So K is a group 1 element, so its oxidation number is +1. Obviously chlorine is -1. Now if you consider a group 2 element like calcium, magnesium, then because they can lose 2 electrons, so the oxidation number for the group 2 elements like magnesium, barium, calcium, that is +2. Now fluorine is the most electronegative element. That means no other element has got a greater power to attract electron towards itself. So fluorine is the most electronegative element in the periodic table. Therefore, and it can accept one electron, so its oxidation number is always, it cannot be any other because it's the most electronegative, always -1. For example, if you consider Kf, then K is +1, fluorine is -1. Now hydrogen can have two oxidation numbers, either +1 or -1. So when is it +1? For example, HCl, it is +1, chlorine is -1. But if you consider a compound such as NaH, now NaH is sodium hydride. Now you can see that sodium is written on the left side. So generally on the left side we write the positive oxidation number. So right side must be negative. And sodium has got more tendency to lose one electron. So we cannot make this as +1 because then we'll have to make this as -1, right? So this looks quite unnatural, right? So we cannot consider this way. So what we have to do, we have to decide according to the electronegativity. So hydrogen here becomes -1. See, it's -1, and here sodium is +1. So when hydrogen is combined with a non-metal, then hydrogen is +1, and when hydrogen is combined with a metal like sodium, then hydrogen is -1. So I think you understood what I tried to explain about this. Okay, so let's now consider some more examples. Now we go to the example of oxygen. Now oxygen, if you consider, oxygen has got atomic number 8, It's got 2 electrons and then 6 electrons. So you can see that it has got a tendency to gain 2 electrons to complete its octet. So obviously the oxidation number for oxygen should be -2, which is mostly it is -2, but there are exceptions. Now what are those exceptions that we are going to discuss? What are the exceptions? So we are going to discuss that. What are the exceptions to the oxidation number for yes, so what are the exceptions for the oxidation number of oxygen? -2 is most common, but let us consider a compound OF2. This compound exists, right? Now you know that we have already told that fluorine gets always -1. So fluorine gets an oxidation number of -1. So if two fluorines combine together, the total charge becomes -2. And to balance this -2 charge, oxygen should have a +2 charge. That means what is the oxidation number of oxygen? It is +2. It's +2. So when oxygen is combined with a more electronegative element like fluorine, then the oxidation number of oxygen can be +2. Now there are peroxides. Now what are peroxides? See, H2O2. See, H2O2. This is called hydrogen peroxide. Now let us consider this example. Now you know that for hydrogen it has to be +1 because hydrogen is combined with a non-metal. So it's +1. So 2 hydrogens, it is +2, right? So this must be -2 so that the charges are balanced. So there is a -2 charge for 2 oxygens. So what is the charge on 1 oxygen? Obviously it is -1. So we say that the oxidation number of oxygen is -1, not -2. We have to consider one atom. So in peroxides, the oxidation number of oxygen is -1. So we find that oxygen can have 3 different oxidation numbers depending upon the compound. Most commonly it is -2, like for example if you say copper oxide, right? So +2, -2, right? So generally it is -2. When it is combined with fluorine, then oxygen becomes +2, and in peroxides like H2O2. So how will you recognize a peroxide? You will always see this O2. O2 when you see in a covalent compound, then it indicates a peroxide. So this is hydrogen peroxide. For example, if you write BaO2, right, then it is barium peroxide, right? So here also oxygen is -1, 2 oxygens -2, barium obviously is +2 because it's in group 2. So that is how we can decide the oxidation number of the element by considering some rules that I have explained to you over here, right? So now let's go to some other examples and some other uh, concepts for considering the oxidation number. So let's see that. Just just think about these examples which I've explained. Just go through it. Just go through the rules. Just see that whether you really understand those rules or not, right? So we will all see that. Then we will see some other rules also where you will see that how we apply those various rules. Okay, so let's go to the next slide. This is quite obvious that if you directly see a charge like Al plus 3, then the oxidation number is +3. Then this rule, the sum of oxidation numbers in a compound is 0. That we have already considered, but I'll give you one more example. Let us say that we have an example like HNO3, right? Now see, here hydrogen is +1, we already know, so +1 because there is only one hydrogen. Oxygen -2, there are 3 oxygens, so -6. So now what should be the value for nitrogen? Obviously the answer is plus 5. Why? Because the sum, this sum which you write on the lower side, this sum should be equal to 0. It's a compound. So the sum of the oxidation numbers in a compound is 0. So see this, plus 6 minus 6, it's 0. So I think you understood this rule, and this rule can be applied to any compound, which whether it is HNO3 or it is any other compound, you can apply that. Now the sum of oxidation numbers in an ion, let's see what do we mean by this, of an ion, right? For example, sulfate, SO4 2 minus, this is called as the sulfate ion. Now what about the sum of the oxidation numbers, right? Now let's see. So going according to the rules, we can always give a -2 value to oxygen, that we have already learned from the rules. So for 4 oxygens, the total should be -8. Now what about sulfur? Can it be +8? Because +8 minus 8 is 0? No, it won't be +8. Why? Because this is an ion, sulfate ion, right? So it is SO4 with a 2 minus. So now the sum should be equal to 2 minus. That means the oxidation number for sulfur should be +6. Now as you see, +6 and then -8 is equal to -2, which is the charge on the sulfate ion SO4 2 minus. So the sum of the oxidation numbers in an ion is equal to the charge on the ion. So the charge on the ion is 2 minus. So sum of the oxidation numbers should be equal to the charge on the ion. So I hope you understood this. And if you consider a compound or an ion, the more electronegative element is given the negative. For example, when you consider OF2, right? So we always considered oxygen as -2, but here we didn't consider oxygen as -2. No. Why? Because fluorine is more electronegative. The more electronegative should be given the negative value. So fluorine gets -1, 2 fluorines becomes -2. The total, this is a compound, this is not an ion. So total of all the oxidation numbers should be equal to 0. So oxygen therefore becomes +2. So this is how we decide about the oxidation number, and this helps us. Now one of the most important things that you have to understand is that why are we doing all this? What is the significance of all this? The answer to that is that this concept of oxidation number that we discussed over here is very helpful in understanding and in a better way about the concept of oxidation. The redox reactions can be more easily understood with the help of the oxidation number concept. Okay, now let's consider that you have to understand that the same element can have different oxidation numbers in different compounds. For example, let us consider, see, you have heard about sulfur dioxide and sulfur trioxide. Now oxygen is obviously having the charge of -2, so here -4. So to balance it, sulfur should be +4, but here -2 into 3 -6. So to balance this, sulfur should be +6. So see, sulfur is having a +4 oxidation number in sulfur dioxide, but it is having a +6 oxidation number in sulfur trioxide. So the same element can have different oxidation numbers because it depends upon the other element and the number of atoms of the other element with which it is combined. So this +4, therefore we said that it's the apparent charge, apparent, not the real, this is not the real, this is apparent. It appears to have a +4 charge. So the apparent charge which an element has is also known as its oxidation number. Here it appears to have a charge of +6. But on the other hand, you can even consider an example of H2S. See, here hydrogen must be +1, so this is +2. So to balance this, sulfur is -2. So see, here sulfur is -2, here sulfur is +4, here sulfur is +6. If you write only sulfur, then its oxidation number is 0. So the same element in different compounds can have different oxidation numbers, and we can understand oxidation and reduction in terms of oxidation number. As you know that this must be oxidation because one more oxygen is added. So what happens to the oxidation number? +4 becomes +6. So we can say if there is an increase in the oxidation number, it indicates oxidation, and if there is a decrease, for example, if you go from +6 to +4, if you consider the decrease in the oxidation number, then it is reduction. So the concept of oxidation reduction helps us to understand oxidation reduction redox reactions in a more sophisticated manner, where it may not be obvious to you that oxidation or reduction is taking place, but when you apply the oxidation number concept, then if there is an increase in the oxidation number, it indicates oxidation, and when there is a decrease, it indicates a reduction. So this is some more idea that in this lecture basically you understood that what is the meaning of oxidation number and how do we apply the concept of oxidation number to find out the oxidation number of elements in different compounds, and the same element can have different oxidation number in different compounds. Hope you understood all this, and in the next lecture we will discuss some of the exam questions so that you get a complete idea how the examiner asks the questions and whether you are able to comprehend those questions and also answer those questions. Hope you understood the lecture properly. If you understood, please like and give your comments. Thank you very much.